Let's continue looking at indices that are fractions. In our previous video, we saw where if you have a number raised to 1 over n, whatever n is, what you get is the nth root of that number. Alright? So the index here is a fraction. But you have other type of fractions. This is just 1 over a number. Suppose you have a number other than 1 over another number. Suppose, for example, I want to find out what is 4 to the 3 over 2. This would be the same as 4 as 1.5, right? Same as 4 as 1.5, but let's keep it as mixed as improper fraction. And if you don't know, if you don't remember what that is, you have to review your fraction, because we're looking at indices that are fraction. Alright. What is 4 raised to the power of 3 over 2? Let's see. Now, the third law says x to the a, all of that to the b is same as x to the ab. So if you have x to the a times b, you can go back and separate them, the powers, and say x to the a times b. So 3 over 2 is the same as half times 3, right? Alright. Same as half times 3 over 1. I could write it that way as well. But 3 over 1 is the same as 3. So 4 to the 3 divided by 2 is the same as 4 to the half times 3. Now, in our previous video, we saw that 4 to the half is what? Is 2 squared to the half. And then all of that is raised to the 3. It's to the 3. See that? But 2 squared to the half is same as 2 to the 2 times a half. And of course, all of that is now raised to the 3, right? Well, 2 times half is 1. So let's continue down. So this is 2 to the 1. And all of that is raised to the 3. But 2 to the 1 is just 2. So it's 2 raised to the 3, right? 2 raised to the 3 means 2 times 2 times 2. You have 3 2's lined up and they multiply. And that gives you 8. So 4 to the 3 over 2 is 8. Now, you notice here, let's backtrack a bit. Here, when you say 2 to the 2 times half, this is really the square root of 2, of 4, I mean. 2 is the square root of 4. So here, 2 to the 1 is the square root of 4, right? And what you had was 4 raised to the power of 3. See that? Square root of 4 raised to the power of 3. Let's look back at this. 4 to the 3 over 2. 4 raised to the 3 over 2 is the same as the square root of 4 raised to the power of 3. Right? See that? So now, the 2 represents the root here, the square root, the 2 root. Remember, with square root, you could write the 2 here, but it's not conventionally practiced to write the 2 there. If it's cube root, you have to write the 3. If it's 4 2 3, you have to write the 4, and so on. So the bottom number, the denominator, is the root. The top number, it was raised to a power. 2 to the power of 3. So it's the power or the index. Right? Let's write power. The power that you raise the number to. Now you could try with other numbers, but generally, what happens is this. If you have x raised to the power of, what would I say, a over n. I use n because I use n up here already. This is equal to, now, the nth root of x and raised to the power of a. Alright? Now notice, you could also have raised x to the a first. Now this in the bracket, you do what is in the bracket first. So you find the nth root of x and after that you raise to the a. But the fact is, you could also have found x to the power of a first, and then you find the nth root of all of that, right? But when you're using numbers, it's better you find the root first because you're dealing with smaller numbers that way. If you find, hold on, what did I write here? Let me rewrite this part. Let me rewrite this part before I go on. Yeah. So, you could say x to the a first, and then to the power of n. Right. In this case, you do what is in the bracket first. You find x to the a, and then you find the nth root, right? Now, as I was saying, when you're dealing with numbers, it might be easier to find the root first and then raise to the power. You're dealing with smaller numbers there. Suppose you have, for example, now, 25 raised to the power of 3 over 2. You want to find out what that is, right? This means the square root of 25 and then that raised to the 3. Square root of 25 is 5 and that raised to the 3. 5 to the 3 is 5 by 5 by 5. 5, 5, 25, 25, 5, 125. You get your answer. Now, I found the root first. But suppose you raise to the power first. You'll be dealing with bigger numbers. 25 raised to the 3. And then you're going to find the square root of that. And you have to be using a calculator. Suppose you're not allowed to use a calculator. What will you do? You'll be in some problems there. Because you have 25 by 25 by 25. So it's 25 by 25 by 25 equals. You have 15,625. You're going to find the square root of 15,625. Right? You have some very big numbers to deal with. Let me go back to my calculator. Where's my calculator again? Oh, it was this one. Right? So, we're going to now have to find the square root of this. Square root of this equal 125. And you get your 125, right? But as I say, if you get a number to raise to a fraction, and if you are supposed to show working, what you do is find the root first. So you get a smaller number and then you can raise that to the power. So basically, here, a number x to the a over n. Mean the nth root of x and that to the a. The numerator is the root of the number you're finding, and the denominator is the root of the number you're finding. That's the number you're dealing with, x. The root, denominator is the root. The numerator, the top number, is the power that you raise the number to. Alright, so that will be it for now.